So welcome to the day 1 of a new chapter, that is exponential functions. So the concept of this topic is very straightforward, very simple. Just listen to whatever we are going to do from now onwards, and in today's class, after some basic understanding, you are going to solve so many problems by yourself. So just be ready. Let's first understand the topic and then start with our pen and paper and solve so many questions in today's class. So just listen to this basic understanding carefully, because the entire chapter is in a way based upon the logic which we are going to study right now. So it is very simple. Just hear this properly. So now we are going to deal with exponents, which means a simple power of a number. Let's say if someone gives me a square. Someone gives me the expression a square. So I know that a square actually means a being multiplied with a. Or let's say someone gives me a to the power 4. So I know that it means a multiplied by a multiplied by a multiplied by a. And just actually expanding this logic further, if someone gives me a to the power minus 1. So this power minus 1 in the power actually means that it means simply 1 upon a. So a to the power minus 1 is actually straightforward 1 upon a. Or I can write 1 upon a as a to the power minus 1, because it is a to the power at the bottom, and if I take this term in the numerator, it would become a to the power minus 1. Similarly, a to the power minus 2 would make it 1 upon a square. So this is the basic understanding. So at this moment in the beginning, the questions which we are going to deal, at least in today's class, would deal with powers which are only integers. In today's class, we are going to deal with questions in which the powers would be integers, like the example which we are doing right now. Look, all these are integers, minus 1, minus 2, and all these stuff are straightforward integers. So very straightforward, very simple. So whatever we are going to do is actually based upon some very basic formulas, out of which let's say one is this, that if I take any number where a represents any number, any algebraic expression whatsoever, if a is having a power m, and if I raise this entire expression to the power n, so a to the power m whole to the power n actually means a to the power of m multiplied by n. Similarly, in exactly the same sense, let's say if we are doing a to the power m and I am multiplying this term with a to the power n, the bases are same. Just have a look at this basic concept that the base is the same, just the powers are changing. So this gives me a to the power m plus n. A to the power m whole to the power n is equal to a to the power mn. So I'm just giving some examples as well of the same logic. Let's say this is the expression. Let's say someone gives me the term 2 to the power 3 to the power 7. So I directly know that this would become 2 to the power 3 multiplied by 7, that is 21. Similarly, if someone gives me the term, let's say 5 to the power minus 2 to the power 3. So this entire expression would become 5 to the power minus 2 multiplied by 3, that is minus 6. So this is the sense of the first formula. So just remember this basic logic clearly, nothing special, very straightforward. So this topic is actually very simple. So by the end of this topic, you will realize that this can be done so fast and so easily that any question from whatsoever book it actually comes in front of you, you would be able to solve it within a minute actually. Next is a to the power m multiplied by a to the power n. So let's say someone gives me the term 2 to the power 3 multiplying with 2 to the power 7. So we can see that the base is 2, just the powers are changing. So this would give me 2 to the power 3 plus 7, which is straightforward, can be written as 2 to the power of 10. So this entire expression can be represented with this logic. Similarly, now comes the third point, which means that when a to the power m is divided with a to the power n, it gives me the term a to the power m minus n, which if you notice is actually just an extension of this formula only. How? Because this a to the power n in the denominator can be taken to the numerator to be written as a to the power minus n. So now this term and this term are in a way multiplying. So this would be giving me directly a to the power m minus n. So it is the same logic. So whatsoever be your way of looking at it, the sense would remain the same. So there could be so many questions which can ultimately come up by combining these logics. Let's say someone gives me the term 2 to the power 3 multiplying with 2 to the power minus 5 whole divided by 2 to the power minus 7, and we are told to simplify this expression. So I can directly see that since this in this entire expression, this is also 2, this is also 2, and this is also 2. So this can be written as in a combination. This could be written as 2 to the power 3 and further this minus 5, and this term is, since this is in the denominator, so this divided by this would give me 3 minus 5 minus this minus 7, because we know that a to the power m divided by a to the power n gives me a to the power m minus n. So just the entire chapter is in a way based upon these three basic logics, which are very straightforward, which we have in fact in a way done so many times earlier as well, but now we are going to apply it formally as a complete topic. So this is like this term would ultimately give me 2 to the power 3 minus 5, which is minus 2, and minus minus becomes plus, so it would be 2 to the power minus 2 plus 7, which means 2 to the power 5. So this would be the simplified version, and 2 to the power 5 when simplified further is actually 32. So this is the sense. So in this entire topic we have to just focus upon only this basic understanding, and we already know that any number to the power 0 is actually equal to 1. So in a way we can name this as the fourth point. So any number to the power 0 is actually 1. A to the power 0 is straightforward 1, which is something which we actually already know. So I'm just listing down all the formulas which we are going to use in the coming in these questions which you are going to solve right now. So today's class is now based upon only this much of the page which we have discussed right now.